So we saw the mathematical formulation for the riser sports problem, and we also solved it using a graph. We are going to today solve it using Solver. Solver is a free add-in on Excel. If you don't already have it, you can just simply go to options and add it in. So the formulation was where we said let A be the number of all pro footballs to be produced, C to be the number of college footballs to be produced, and then we had various constraints for cutting and dyeing, sewing, inspection and packaging, maximum production of A, maximum production of C, and then we said A and C both will have to be non-negative. The objective here was to determine the number of A's and C's which will maximize our total profit, 50A plus 40C. So let's see then, how can we put this formulation on Solver? So open the Solver sheet that is with you, and what you will see over here is part of the data, or the data has been filled in. So what we do know is A will take 12 minutes in cutting and dyeing, 9 minutes in sewing, and 6 minutes in inspection and packaging. That data has already been entered here. Similarly, the time that C will take in these three departments, 6, 15, and 6, has also been entered. The total capacity in minutes in cutting, dyeing, sewing, and inspection and packaging has also been filled. The amount of profit that we stand to make from A and C is 50 and 40, and that data has already been filled as well. Now, in order to solve this problem, we need to figure out how much of cutting and dyeing time will we use if we make A all pro footballs and C college footballs. So on our spreadsheet, B4 is the cell where Solver will tell us how many A-type footballs to make, and C4 is the cell where Solver will tell us how many college footballs to make. As of now, these values are not known to us. They are variables, they are unknowns, and those are the values that we want Solver to determine for us. All right, so in order to do that, in order to give Solver the constraints, so let us give Solver the constraints. The first constraint should say the amount of time that A and C will use in cutting and dyeing has to be less than or equal to what we have available, which is 20,400. So let us then figure out how much are we going to use. We're going to use 12 into the number of A footballs that we make plus 6 into the number of college footballs that we are going to make. Now that is the total time, which is exactly the same as we wrote earlier as a constraint. So that's the total amount of time taken in cutting and dyeing, which should be less than or equal to 20,400. Just for a sanity check, we can maybe just enter some numbers here. Let's just enter 1 and 1 so that we know that we're doing the right thing. So I could copy this formula for my sewing hours and inspection and packaging hours used, provided I fix A-type footballs that I make and the number of C-type footballs that I make. So that will then remain as B4 and C4. And then now I can copy this. So let's see. What do we get here? We get B6 into B4 plus C6 into C4. 9 into A plus 15 into C is the total time that we will require in sewing if we make A all pro footballs and C college footballs. And that then has to be less than or equal to 25,200. So that's exactly the same thing that we wrote earlier as a constraint for sewing. And similarly then, here is what we have for inspection and packaging. B7 into B4 plus C7 into C4. That is 6 into A plus 6 into C has to be less than or equal to 12,000. That was the inspection and packaging constraint. We can ignore for now the maximum production constraints simply because Those were redundant constraints, if we remember. But if we wanted to add them, we could add them. But for now, let's not add them simply because they were redundant.